All right, once again, it's Akimbala Kendi, and I'm making this video as a follow-up from where I stopped last week in my documentation of my journey as a Web3 developer here at Web3 Bridge Learning Facility. And we just concluded the week 5, so technically that marks my 6th week here in this learning facility. And we did quite a number of things in this last week, and we did something quite interesting. We wrote an eviction text, and hopefully I think I scaled through because my code kind of worked. So yeah, and basically we built quite a number of contracts. Yeah, we worked on a token voting contract such that you have to have a number of tokens for you to vote, and then we also worked on NFTs, and actually it was given to us as an assignment, and we're asked to write NFT contract and deploy it to testnet while making use of any decentralized storage platform to host it. So we used platform like Pinata, IPFS, or Firebase. Anyways, I made use of Firebase, and the trickish thing is that I'm currently in Nigeria, and it seems that Firebase is not available for developers in Nigeria. But I had to do a workaround that so that I would do make use of Firebase. Anyways, it worked, and I'm going to show you my NFT on testnet, OpenSea testnet rather. And also we did something on learning how to fork the mainnet. Yeah, we forked the mainnet such that we brought the current block on the mainnet to our local machine, and we're able to impersonate someone's account, like a real life account, although whatever we do with that account only stays within our local machine. So we did that too as well, and we also interacted with uniswap contract. So all we had to do was just to build an interface for it, and we interacted with uniswap using a script. Although I made use of TypeScript, some of my colleagues made use of JavaScript. Anyone works just fine. So I'm going to show you my code just in a little. Well, okay. So let me just show you my code right now. So basically, this is the token voting contract, such that you would need to have a couple of tokens before you can vote. And as you're voting, about 3 tokens will be removed from your balance. And I've created a modifier over here to mitigate against various instances of voting for the same person over and over and over again. Although I'm still trying to figure out a way to make, instead of making this line of code multiple, I'm looking for a way to compress it to just a single line of code. So I'll just iterate through possible scenarios, and then I'll mitigate against that. So this is something I'm working on because I still have a couple of that I did down here. So and one of the things you have to consider as a programmer is that you have to be dry. Don't repeat your code you get, and so as basically things I'm still trying to work out on this code. So basically, I have a function that register contenders, and also function that buys tokens. So if you want to registration is free, but if you want to vote for anyone, you have to buy tokens. And if you don't have tokens, you cannot vote. And I created a voting pool where the whole voting will be packed together. So I have a function to collect votes to get results, and I made a limitation such that only the owner can commence the voting process, and then only the owner can end the vote process. Ends, emptying the whole voting storage, such a way that the next set of voters can come in. And there's one thing: only the people can be voted for at a time. So I'm still looking to create a factory contract such that we can create several instances of voting token contract. So anyone can just go there, create a voting token contract, and then vote on it. So why this is so is to ensure that if 3 people are being voted for at a point in time, others can still create a new instance of that token voting contract and then vote.
and then vote and then carry out their own voting process. So basically, this is and then this is the functions like get the winner of the voting. And then next up is the uniswap, because we interacted with uniswap contracts, and we were able to fork the mainnet, into our local machine. Okay, right. Just like you can see, I can see the mainnet running over here in my local machine. So basically, to just make a duplicate of the current block on the mainnet, and then have it on my PC. And then I did something. I impersonated someone's account, although I won't have access to the person's account, only on my local machine, because that made it available for us. So here is I interacted with Uniswap. All I know was Uniswap interface, because I interacted, just got to the Uniswap interface, and I interacted with just a few of the functions using my script. And I made use of TypeScript anyways. So there we go. So here is the factory contract. This actually enabled me to interact with when considering removing the okay, before I get there, let me just touch adding liquidity first. After impersonated the account over, I had to get the various contract I'll be needing, the various token I'll be supplying for liquidity, the various token I'll be supplying to contract addresses. I added it here, and this router is the Uniswap V2 router contract address. Okay, this holder is the person I'm impersonating. The person I want to use the account information to run things on my local machine. And then this is just the time. So basically, this is the function that helped me to. Sorry, this is the script that enabled me to impersonate the person's account, and I got the content I'll be using. I created an interface for both of them. I token, which I have right over here. It's just an interface that I can interact with those contracts. So yeah, so basically I interacted with the add liquidity. I interacted with add liquidity with ETH, and I interacted with and then interacted with remove liquidity. But this remove liquidity is a bit tricky because I needed to get the pair, and I only got the pair from importing the factory, from interacting with the factory contract of Uniswap, and then I called the get pair on it. Then I got the pair address because I use uni and die. So uni and die is now pairing address and stuff. So that's how I was able to get the balance of a pair address, and then I was able to approve the router, that's the contract address, the router contract address, access to spend the liquidity inside of the paired contract. So and I called the remove liquidity contract, remove liquidity function on it. So it's basically me interacting with a Uniswap interface. There's a lot more, and and then the NFT as well. So basically, I created an NFT contract. Is it? Okay, well, created the NFT contract. So basically, I made use of open Zeppelin library to interact with it, and I used Firebase to host the images on the testnet and stuff, and I created a safe mint function to mint, and then I limited it to just the owner. Only the owner can mint to any address. So and I interacted with this contract from my script. I did not interact with it directly on the testnet interface. I made sure I interacted with it from my script, which I got a balance. I deployed it in my script. I minted to the owner's address my script, and I also minted to another user, another address. with my script. So let me show you what it look like. So after minting this is it on my OpenSea testnet minted. So this is the account that deployed the contract. So let me show you the contract address. Okay, here it is. So you see, create. This is the creating. This is the transaction that shows that I created the NFT. And this is when I call the SafeMint function using my script. So yeah, that's that.
So yeah, that's basically that. Thank you for sticking around to look at my code base. Although it looks ugly, but then there's still room for improvement. So uh, this new week we intend to venture into writing smart contracts, just different case scenarios, and it's likely be writing new contract like every single day for the next couple of days. So when we're done by the end of the week, I would come back next week to tell you all about it. See you next week. Bye.